In this video, we're going to go over number 3 from the Chapter 2 review. And basically what's happening here is we are choosing 6 students from our list of 27 on the tentatively admitted list to move up to the clearly admitted list. And we're looking at the probability that that happens different ways given that we randomly select the 6 students. So first, what's the probability that all 6 of the randomly selected students are students who identify as white? So we always just need to think about our probability as, okay, it's a fraction where the denominator is the number of total ways that whatever event is happening can happen. So in this case, that's going to be how many ways can I have 27 students and choose 6 of them? And the word choose there in that letter C, that's important because there's nothing in the problem here that indicates that the first student we choose is different from the second or the third or the fourth or the fifth or the sixth. It's just a group of 6 students who are all switching from tentative to admitted. And so we would say that this is a combination rather than a permutation. Now, there's a button for that on your calculator, but I'm going to go through sort of exactly what that means here. We're thinking about it as, okay, I've got 6 slots. How many for the first? How many options for the first slot? 27. Then 26 for the second student. Then 25, 24, 23, 22. So I'm choosing 1, 2, 3, 4, 5, 6 students. And this is sort of as if, how many ways could I choose the first student? Well, now that I've chosen that first one, how many options do I have for the second? But again, this implies that the order in which I choose those students actually makes a difference. But that's not true. So we then just have to divide this by saying, okay, well, given any grouping of 6 students, how many ways could I rearrange them? Well, that's 6 times 5 times 4 times 3 times 2 times 1. That's going to give me a number which is 296,010. That's how many ways we could randomly choose 6 out of these 27 students. Now I also need to say, well, okay, how many ways could I choose 6 students so that all 6 of them are white? Well, we are told in the problem that 9 of the students are white, and we're choosing 6. So again, I'm going to say, well, how many options do I have for the first student? 9. For the second, 8. For the third, 7. 6. 5. 4. But, again, the way that that's written, that implies that how many ways for the first student I choose, how many for the second, how many third, fourth, fifth, and sixth. That implies that the order in which I choose the students is important. But that's not true. So I have to then divide out how many ways I could rearrange any particular grouping of 6 students. And if I simplify that all the way out, I'll get 84. So, oops. Okay. Everything's just moving together weird there. We'll go horizontally here instead of vertically. So if I actually then divide this thing, I'm going to get a small decimal. It's 0.000284, which is fine. That's the answer. But the directions say we should have a percent rounded to the thousandths place. So I'm not going to round to the thousandths place and then turn it into a percent. I'm going to turn it into a percent and then round that to the thousandths place. So as a percentage, this should be 0.028%. All right. Now, the second part here, part B, is basically the same thing. It's just that what I want to happen, and want is the wrong word, but what I'm interested in happening, originally was all the students being white. Now it's switching to, well, what about 3 being Asian and 3 being American Indian or Alaska Native? So this numerator needs to change, but the denominator should be the same because we still have 27 students and we're still choosing 6 of them. So the total number of ways that this selection can happen should still be 296,010. It's just the numerator that needs to be changed. So let's do that. And if you're like, oh no, I didn't write it all down. Well, it's a video. Go back. Pause, rewind. Okay. So now I need to figure out, well, what is the probability, or excuse me, how many ways can I choose 3 students who are Asian? Well, I need to know how many there are. 5 who identify as Asian. So there are 5, and I'm choosing 3 of them. And 3 of the students American Indian or Alaska Native. Well, there's only 3 of those. And so once again, I need to think, okay, what am I doing here? Well, I'm choosing 3 students. I have 5 options for the first, 4 for the second, 3 for the third, but I can do it in any order I want. So I need to divide out the possible rearrangements of any particular grouping of 3 students. And I can do the same thing for the next part, but if I just think through it, there are only 3 students. Out of that group of 3, how many ways can I choose all 3 of them if the order in which I'm putting them doesn't matter? Well, there's only one way to do it. Just choose all 3 of them. Now, if the order was important, that's different, but here it's not. So it's just 1. And if you simplify the first one, you will get 10. So I have 10 over 296,010. There are 296,010 total ways I could choose 6 out of my 27 students, but only 10 ways that I could get 3 Asian and 3 American Indian or Alaska Native. So if I do that, I'm going to get a very small decimal, 0.0000338 approximately. Rounded, I've cut off a whole bunch of decimals there. Now I'm going to turn that into a percentage, 0.003%. All right, that is number 3.